Hi, this is Alex from devstories.eu, PyCharm's dedicated Python IDE, episode 4 of 5. Asynchronous code makes your applications incredibly fast, right up until a silent deadlock freezes everything and leaves absolutely no error trace. Finding out exactly which coroutine stuck is notoriously difficult. The solution in PyCharm is visualizing async code, the concurrency diagram. Asynchronous code is hard to debug because a single event loop constantly switches between tasks. If you build an async web scraper and it suddenly takes 10 minutes to run instead of 10 seconds, standard logging is mostly useless. Print statements just output a chaotic wall of interleaved text. You know a task is waiting, but you do not know which one or why. You might think you need a standard CPU profiler here. You do not. A standard CPU profiler tells you which function consumed the most processing power. The concurrency visualization feature is different. It is a specialized tool designed explicitly to track thread states and async I/O event loops over time. It shows you when your code is doing absolutely nothing. You access this feature through the Run widget at the top of your IDE. Open the More Actions menu for your run configuration and choose the option to Profile with Concurrency Visualization. PyCharm executes your code and then generates a detailed diagram in a dedicated tool window. Inside this window, select the Async I/O Graph tab. This is where the actual visualization happens. The interface displays a timeline. Each horizontal track represents an event loop or a thread. Along these tracks, PyCharm plots blocks that represent your coroutines. The length of a block shows how long the coroutine existed. This is where it gets interesting. Every block on the timeline is color-coded based on its exact state at that specific millisecond. One color indicates the coroutine is actively running and using the CPU. Another color shows when it is waiting, perhaps for a network response or a file read. A different color highlights when a thread is completely blocked. Apply this to the stalled web scraper scenario. Instead of guessing why the scraper is stuck, you run the concurrency visualization. You look at the async I/O graph and see 10 coroutines launched to fetch web pages. 9 of them show up as a solid block of a waiting color. You can click on those blocks to see exactly which function they represent. You instantly spot that they are all stalled, waiting on a single network lock that a previous coroutine failed to release. Seeing these real-time states natively in the IDE is a massive advantage over manual debugging. It shifts your perspective from reading sequential lines of code to viewing actual time-based relationships. You find deadlocks not by tracing logic errors in your head, but by physically spotting the blocked colors and empty gaps on a visual graph. The single most important takeaway is that asynchronous bugs are usually problems of timing and state, and the concurrency diagram translates those invisible timing issues into a clear visual map. Thanks for spending a few minutes with me. Until next time, take it easy.